Hi everybody, this is a review video for working with parabolas defined by a directrix and a focus. We haven't talked about this since before Thanksgiving, so it's been a while, which is why I made this video for you to review. So on the set of axes below, graph the directrix, y equals -2. Well, that's this horizontal line here. Y equals -2 is a horizontal line. And the focus 2, 4. 1, 2, 3, 4. There's my focus there of 2, 4. We defined a parabola as the set of points that are equidistant from this focus and directrix. So the parabola is equidistant from the focus and directrix. So the first thing we do is once we graph the focus and the directrix is we want to find the vertex. We want to state and graph the vertex of the parabola. Well, the vertex, the key thing, is equidistant. It's the one point that we can clearly graph. How far apart are these? They're 1, 2, 3, 4, 5, 6. So I need to go up 3 to the middle, which is right there. That's the vertex at 2, 1. And that's an important point. The vertex is going to be an important point in writing the equation of this parabola. Sketch this parabola. Well, I know it's concave up. I know it's opening upwards because I can't cross through the directrix. I can't cross through the directrix, so I'd have to go that way. There's my parabola sketch. State an equation of the parabola. So we need to think about this parabola in terms of transformations. Normally, plain old x squared passes through 0, 0 as a vertex, but I have a vertex of 2, 1. So I need to go left 2, up 1. So I'm going to take a parabola and go left 2. Well, how am I going? Sorry, not left 2, right 2. It's a little late at night here, but I should know my directions. I have a master's degree in mathematics education. So we'll go right 2. We'll go right 2 units. So let's go right 2 units. So that's an x minus 2 on the inside, and up 1. Well, first of all, this isn't an equation. I need a y equals in front of that. But the leading coefficient is 1 over 4p. The leading coefficient is 1 over 4 times the focal length. This is the p distance here. The focal length is how far away is the vertex from the focus. Well, it's 3. What do I do with that number? I multiply it by 4, which is 12, and take the reciprocal. So it's a positive 1/12. That's my leading coefficient. So the equation of this parabola comes out to be y equals 1/12 x minus 2 squared plus 1. I went right 2, up 1. Those come from the vertex. That 12 there came from 1 over 4p, 1 over 4 times the focal length. So in general, if you're one of those memorizers and don't like to think about transformations, it's y equals 1 over 4p times x minus h squared plus k, where hk is the vertex. So if I have a directrix and a focus, and here's my vertex here is h comma k, I need to go the opposite of h, the opposite of the x value, plus the k value, whatever that y value is, and then the p is the focal distance, the focal length there. It's 1 over 4 times p. This gives us the parabola that we want to create that focus and directrix there. So a parabola is a set of points that are equidistant from a focus and a directrix. And the equation can be defined using this idea. So find the equation of a parabola as it has a focus of 3, 4, and a directrix of y equals 8. Sketch a picture. I got a directrix of y equals 8 and 3, 4. That's the focus. I really don't care about the focus. I care more about the vertex. Because once I get the vertex, I can plug it into that vertex form to get the equation. I need to be equidistant. Well, how far apart are they? They're 4 apart. 4 to 8 is 4. So half of that would be 3, 6. That's my vertex there. My vertex is 3, 6. This parabola's got to be concave down, though. Why? Because the directrix is above it. Since the directrix is above the focus, I have a concave down parabola. So let's write the equation. y equals something squared. Well, what gets me to this point 3 comma 6? It's the opposite of the x value, go right 3 and up 6. What number goes out front? Well, I need the focal length. I need the focal length. How far away is the focus and the vertex? Well, that's 2. So I'm going to get a 1/8 because I did 2 times 4 and flipped it. But it's concave down, so it needs to be negative. It needs to be a negative 1/8 there, and that's my equation. I use the vertex to get those two values there. Remember, that's opposite. And then you use the focal length times 4 reciprocal to get the leading coefficient there. Which equation represents a parabola with a focus of 0, 1? So I have a focus of 0, 1 and a directrix of negative. Y equals negative 1. Well, what's in the middle of that? Isn't that the origin 0, 0? Parabola is going to be concave up. Well, since the parabola is concave up, I know I don't need the negative value there. I need a positive value. So it's y equals x minus 0 squared plus 0. So it's really just y equals x squared, because those zeros don't matter, but I need a leading coefficient. They're 1 unit apart, so it's 1 over 4 out front. I don't see that here, because what New York State did here is they multiplied that 4 over. So 4y equals x squared. That's how we get the equation of the parabola here. Drawing that picture and finding that vertex is the most important piece. Number 4, determine and state the focus and directrix of this parabola here. So we're working backwards. Here's the equation of the parabola. Give me the focus and directrix. Well, I don't like the way this equation looks, and as much as I don't want to do it, you're going to want to take that -8 and distribute it in. And we'll see in the next problem another way you could have done this without distributing that in. Leave that square alone. Don't expand it out. Leave it alone, because that'll be in vertex form when we're done. I'll subtract 24 to get y by itself. And then I'll divide everyone by -8, which leaves me with y equals -1/8, because that's what dividing by -8 is, x plus 4 squared plus 3. So now that I'm in vertex form here, I can think about my transformations to get my vertex. I can think about the transformations I did to get this vertex. I went left 4 and up 3. I went left 4, up 3. So there's my vertex there, and this parabola is concave down because the leading coefficient is negative. So I need the focus and the directrix. Well, the focus is somewhere inside this parabola. How far away from the vertex is it? Well, where'd that 8 come from? That 8 came from 4 times 2. So I need to travel 2 away. It was the point -4 comma 3. So if I go down 2 units, that brings me to -4 comma 1. That's my focus. My focus is 2 units away at -4 comma 1. The directrix is also 2 units away, but it's 2 units up, and it's a line. So what's my equation of this line here? Well, I was at 3, but if I go up 2, that brings me to y equals 5. Make sure you write the directrix as an equation of a line. Y equals 5, that's the directrix there. So my focus is the point -4, 1, and the directrix is y equals 5. Because we use the vertex, I went left 4, up 3. That's the vertex. I'm concave down because the leading coefficient's negative. And I use that 1/8. Well, how did I get 1/8? Well, I flipped something and multiplied it by 4. Well, that's 2 times 4 is 8. Reciprocal gives me 1/8. So the focal length there is 2. Watch this. Instead of distributing, I'm going to divide by 12. That gives me y plus 3 equals 1/12 x minus 4 squared. And then when I subtract 3, I'll be in vertex form. So I have y equals 1/12 x minus 4 squared minus 3. So my vertex here is right 4. I went right 4, down 3. It's the point 4 comma -3. That's my vertex. My vertex is 4 comma -3. This parabola is concave up because it has a leading coefficient that's positive. Well, how far away do I have to travel to get the focus and directrix? Well, where'd the 12 come from? The 12 came from 4 times 3. So I have to go up 3. Adding 3 to my y value gives me 4, comma 0. That's my focus. And down 3 gives me my directrix of y equals negative 6. That's my directrix. My focus is 4, comma 0. My directrix is y equals negative 6. The parabola here has a vertex of 2, comma negative 6. So let's draw that. 2, 1, 2, 3, 4, 5, 6. That's the vertex. The leading coefficients positives are going to be concave up. The focus is 2, negative 5. Explain how you can determine the equation of the directrix. Well, the key thing is the parabola is the set of points that's equidistant from the focus and directrix. So if the focus and vertex are 1 away, I have to go 1 in the other direction. So I need to go down 1. I need to go 1 away from my y value, which gives me a directrix of y equals negative 7. But it says explain how I got that. So since the focus to vertex was 1 unit, the vertex to the directrix is 1 unit. I subtracted 1 from negative 6 and got y equals negative 7. So the key thing here is when we work with focus and directrix, it's the set of points that are equidistant from the focus and directrix. That's a parabola. The parabola is the set of points, and the key thing is we need the vertex. The vertex is the most important one because that helps us write the equation in the form of 1 over 4p x minus h squared. I need to shift right. Remember that inside shift is opposite, plus k.